Hello everyone, very good evening. Today I am going to explain the NCERT section of chapter 2, Force and Laws of Motion, which is given in your textbook. Okay, so let us discuss all the questions. All the questions I will explain each and every answer in detail, and you also make a note in your classroom. Okay, so if you observe the first question, the question is which of the following has more inertia? As we all know, inertia is a property. Okay, which means the tendency of a body. If a body remains at rest, it will be remain at rest only. If it remains in motion, it will remain in motion only according to Newton's law. Okay, Newton's first law. Now let us see here. Few examples are given. First one, a rubber ball and a stone of the same size. If you compare these two objects, one is a rubber ball and another one is the stone, right? So which will have a more mass? Tell me. Stone, right? Because stone has more mass. Answer I will be writing here. What you will write? Stone has more mass, so it it will have more inertia. So inertia depends on mass. Okay, that you have to keep in your mind. More mass, more inertia. Same way. Okay, the answer also, because stone has more mass, so it will have more inertia. And second example, if you see B, option B, option B. What is the question? Question is a bicycle and a train. Which will have more mass? Train, right? So train has more mass, okay, than bicycle. Okay, bicycle. So it will have more inertia. Okay, you note down the answer. Similarly, C. What is the question? A 5 rupees coin and a 1 rupee coin. So which will have more mass? Tell me. 5 rupees coin. So you will write the answer 5 rupee. 5 rupees coin will have more mass. Will have more mass. So it will have more inertia. Okay. It will have more inertia. Okay. So in the first one there, here I have written getting wrong. Okay. So inertia. So these are the three answers for first question. Now second question, I'll read out and I'll explain. Okay. Fine. So let me erase the first one. I hope you have noted it down. In the following example, okay, there is an example given. Try to identify number of times the velocity of the ball changes. We need to find out how many times the velocity of the ball is changing in this example. So what is the example? A football player kicks a football. Okay. So let us consider that he is a football player. He's a football player and he is kicking the football. Okay. He kicks the football. Just okay. He kicks the football. Now what happens is, let me explain you. Now what happens when he kick the football? Wait for a while. Yeah. So when he kicks the football, what happens? Football will move. Okay, it will move in the direction which he kicks the ball. Okay, now what is happening? A football player kicks a football to another player of his team. So what this first player will do? He will definitely kick the football towards the another player, right? Suppose if another player is here, so he pass the football to him. So now football goes to him. Okay, so now you see first condition for first example. Firstly, he is kicking the football. Then what happens to the velocity? Velocity changes in the first case. When the first player kicks the ball, velocity changes. Now it goes to second player, and what the second player is doing to another player of his team who kicks the football towards the goal. Now the second player is, imagine, he is the second player and he is kicking the football towards the goal. Then when he kicks the football towards the goal, again velocity changes. Here also velocity changes. Now, the third example, the goalkeeper of the opposite team. Okay. Now, we all know that the goalkeeper will stand near the goal, and he always try to stop the ball. So, what is he doing? Goalkeeper of the opposite team collects the football. So, he collects the football, right? So, when he collects the football, it means if the ball is coming with more speed, when he collect the football, the speed decrease. Then velocity here also changes. Now he's collecting. How he will collect? He will collect with the hands. And the fourth one, and what he's doing, and kicks it towards a player of his own team. Now the goalkeeper, after collecting the football, he is kicking towards the another player of his own team. Now you see how many situations are there. One is first one, kicking a football player kicking the football towards another player of his own team. Then velocity is changing when he's kicking. Secondly, second football player kicking, velocity is changed towards the goalkeeper. Goalkeeper uh, collects the football. So velocity change third time, and finally again he is kicking. So four times. So how many times? So number of times. Our question is to find out how many times. So number of times, how many times? Then four times. You can write. I'll write the answer here. The velocity changes. The velocity changes. The velocity changes four times. Okay. Now, question is not completed yet. He's also asking. He's also asking. Uh, Also identify the agent supplying the force in each case. Okay. He's asking to find out the agent. So I'll write the agent. Okay. So first one, if you take the first example, who is the agent there? In first case, first football player. He is the players. The players the player's feet are foot, right? Similarly, what about second player? Second player, I'll write here. The agents are the agents are foot for first and second player. I hope it is clear. And what about the third person is doing? Third person is the goalkeeper, na? The goalkeeper is collecting the ball. So collecting with what? Hands. The agent for the goalkeeper is his hands, or his hand. The goalkeeper is his hands. Now, what about what the goalkeeper is doing? Again, he is kicking the football towards the another player. So, kicking, what he is doing? He is using his again foot. Okay. So, the uh, agent for fourth time or fourth time. So, the first situation, foot. Second situation, foot. Third situation, goalkeeper, hands. And fourth situation, agent for fourth time, uh, is his foot. I hope it is clear. So this is the answer for the second question. Okay. Now let us discuss the third. I hope you have understood. Any doubt if you have, you just mention in the comment box so that I can clarify. Now explain why some of the leaves may get detached from a tree when vigorously from a tree when vigorously if we vigorously shake its branches. Okay, imagine it's a tree. Okay, so tree will have leaves to it, and these are the branches. Okay, and let us consider I'll be using the green color. All these are the leaves. So if we vigorously shake the branches, what happened? Leaves fall down. He's asking why. Again, it is because of inertia. Okay, I'll write the answer here. Answer will be when we when we vigorously vigorously vigorously, sorry, vigorously shake the branch of a tree. Now, which will come to motion? Tell me. Branch will come into motion. Then what about the tree? Sorry, what about the leaf? Leaf will remain. So leaves will remain at rest. So due to inertia, the leaf gets separated and will fall down. So branch of a tree, the branches come into motion, but the leaves tend to remain at rest. Why? Due to rest, due to inertia, inertia. So inertia. So the leaves detached, okay, detached from the branches and fall down. Okay, I hope you have understood it. Okay, any doubt? I told you very clearly in the beginning. Mention in the comment box. So this is the question answer for third question. Okay, let us discuss the fourth one. You may pause the video and listen again if you want. Why do you fall in the forward direction? Very important question. Why do you fall forward direction? Why do you move in a moving bus? Okay, bus when brakes are applied. Okay, suppose let us imagine that he is a driver in the bus. Okay, and he is riding the bus, and you are sitting behind the driver. Just imagine you are sitting here. Okay, behind the driver. Okay, now it is a moving bus. Okay, and then again fall backward. There are two conditions. One is fall in the forward direction. Second one, fall in the backward direction. We need to identify what is the reason here. So here, what happens when bus is moving? If you observe suppose these are the legs. Okay, his feet. Feet is in contact with the bus, right? Okay, I hope you understood. His feet uh, in the contact with the bus. So when bus is moving, what is the condition of his feet? That will also in motion only, right? So when the driver applies brake, bus come to rest. Yes or no? Exactly. When bus come to rest, then what about his feet? Feet also try to come to rest. Why? Due to inertia, because he is applying the brake now. Now what about his upper body? His upper body is in the motion towards forward direction. Are you getting my point? So only feet are in contact with the motion of the bus, and the upper body is still in the movement state. It means still in the forward motion direction. So that is the reason when driver applies the brake, feet come to rest and upper body try to be in the state of motion. That is the reason the person will fall forward direction. That is the answer. I'll write the answer here. Okay. Fourth answer. Fourth answer, note down. When the uh, brakes applied, and the brakes applied, our feet come to comes to rest, but but the upper part of our body continue to move in forward direction. Why? Due to inertia of motion. Okay, due to inertia of motion. So we tend to fall, okay, in forward direction. Now next, what is he asking? Why we fall backward when accelerate from rest? Suppose if you are traveling to some other place, you'll enter into the bus and you'll sit down, right? You'll be sitting down for some time. When after some time driver comes and driver start the bus. It means before it is rest, and when he start and when he accelerated, it will start movement. So now the question is like why we fall backward. Previously it is forward direction. I told you why. Then now why for backward direction? Okay. Now what happens when suddenly when the driver applies when the driver start the bus? So what will happen is when the bus accelerates from rest. When the bus accelerates from rest, the part lower part body of the body tries to move with the bus. Understood, all of you? Okay, lower part again, your feet. Okay, try to move with the bus. But what happened? Upper part, but upper part the upper part of the body. This is the answer you note down. Okay, upper part of the body tries to maintain rest. Why? Because because due to inertia of rest. Inertia of rest. So we fall backward backwards. We fall backwards. Okay, this is the answer for fourth one. Okay, I hope you have understood all four answers. Okay, now note down the fifth question. Fifth question. What is the fifth question here? An object experiences a net zero external unbalanced force. Net zero means what? Tell me. Net zero external experience a net zero. Net zero external unbalanced force. Is it possible for the object? Is it possible for the object to travel? Okay, to travel with a non-zero velocity. Okay, are you getting my point? Is it possible for the object to travel with non-zero velocity? It means, see here the question try to understand object experience a net zero external unbalanced force. Zero external unbalanced force the body experiences. Okay, imagine suppose this is a bus and bus has experienced a zero external unbalanced force. Some external unbalanced force and whose force is zero. Net force is equals to zero. Like this zero net force applied on the bus. Now the question is now is it possible and that too this it is um, unbalanced. Now he's asking is it possible for the bus to travel with non-zero velocity? Yes, non-zero velocity. Why not? If yes, state the condition that must be placed on the magnitude and direction of the velocity. If no, provide the reason. Very simple answer. You note down the answer. Yes, I'll be writing here. Yes. It is possible. Yes, it is possible. Possible when in two conditions. Possible when first one I'll be writing when the magnitude. Note down when the magnitude of velocity does not change. When magnitude means value. If the value does not change, what happens? The bus will go with a uniform speed. That is what he's asking. Or uniform velocity. Yes or no? That is what he's asking. Non-zero velocity. It will go with a non-zero velocity. And second answer you note down. Second answer. Another one is when the direction and when the direction and okay you can write that and magnitude when the direction and magnitude of the body of the object or body of the object does not change. Okay, does not change. When direction also and magnitude, when direction does not change, if the body is going in a straight path, so then velocity velocity can be remained constant. Yes or no? So these are the two conditions, and one more condition is also there. You may write down, you may note down that condition also. Okay, when okay when the resistance when the resistance to motion due to air must be zero. Are you getting the point? When the resistance due to motion due to air, what happens if bus is moving? Suppose if this bus is going in the forward direction, if bus is going, this pen is going in the forward direction, opposite side, air resistance will act. Yes or no? Air resistance. It will act in the opposite direction. That should be zero. Then that time velocity won't change. So these are the three reasons for the fifth question. Please note down. Next one. The next question is, when a carpet is beaten with a stick, dust comes out of it. Explain. Very simple question. Imagine there is a carpet, okay, and a carpet have, just consider that these are the dust particles. Okay, dust particles which are stuck on, which are stick onto the carpet. Now, what we are doing here, of course, in every house, when the house being cleaned with the broomstick, okay, they actually beat these mats, right, to remove the dust, right? These are same thing. So when imagine here this mat is being beaten by the stick, dust comes out of it. Why? Explain. So now you tell me. Suppose when I beat the mat here, oh sorry, carpet, I am beating the carpet. When I beat the carpet, which will come to motion? Tell me. Carpet comes to motion state. And what about the dust particle? They remain at rest. Why? Due to inertia. So the dust particle comes out of the carpet. Okay. So you may write down the note down the answer. Why carpet is beaten with a stick? Dust comes out of it. Explain. Okay. I will be writing the answer when a carpet is beaten, the dust comes. Carpet is beaten. The dust comes. My battery is low. Just give me a minute. I'll connect the battery. The dust comes out of it because the carpet comes into motion, and the dust particles, okay, tend to try to, or we can write try to resist. Okay, resist means oppose. Try to resist the change. Try to resist the change of change of state, change of rest position, rest is the change of state, state of rest, state of rest. They are in rest position. What dust particle? So they want to be in the rest position only. Why? Due to inertia. Okay. According to Newton first, you can write according to Newton first resist. So the dust particle, so the dust particles comes out of the carpet. This is the answer for the question. Okay. You can simplify also if you want. You can simplify it. Okay. Fine. Let us go to the next question. Why it is advised to tie any luggage kept on the roof of the bus with a rope? Imagine if you are traveling from one place to another place in a bus. Okay. Sometimes you might have observed that luggage has been tied above the bus. Yes or no? With the ropes. He is asking why. Why should we tie? Now I'll explain you very simply here. When the bus is traveling, when the driver is sitting here and the bus is moving in this direction. When bus is traveling, when bus is going moving, suddenly if the driver applies a brake or if he decrease the velocity, what happens? There will be a change in velocity of the bus. Now what happens? Suppose if he applies the brake, imagine bus is moving with 50 kilometer per hour. After some time, if he get on a speed breaker or any turnings, any curves, he apply the brake. So when he apply the brake, what happens? Bus will come into rest. Bus comes to rest state or rest position. Now what about the luggage which is tied on the bus? This luggage try to resist the rest or try to be in motion only. Why? Previously bus is in motion. So when the bus come to rest, luggage try to be in the state of motion only due to inertia of motion. So, so that is the reason it may fall down. I have explained the third answer why we fourth one why we fall forward direction. Same answer for this also. Okay. So I'll be writing the answer. You please note it down. So why it is advised to tie a luggage? It is because luggage, I'll simplify it, luggage tends to remain in state of motion due to inertia due to inertia. Okay, inertia. Hence falls falls down or forward. That is the reason we should tie it. Otherwise, luggage will fall down on the road. Okay, and you will be in the bus. This is what the answer. I hope it is clear. Okay, I have divided it into parts. In the next page, you'll see ninth question and remaining questions. Okay, so first half of the page, first 1 to 8 questions are there, which is similar in your textbook also. So eighth question is: a batsman hits a cricket ball, which then rolls on the level ground. Okay, after covering a short distance, the ball come to rest. The ball slows to a stop because the ball slows to a stop because. So what is he saying? Imagine a batsman when he hit the ball. Imagine a batsman hit the ball. When he hit the ball, what happens after some time? It's rolling on the ground. It's on the ground. After some time, the ball comes to rest. Yes or no? Slow down. It means the speed decreases. Okay. uh, because he's asking. Because here two options are given. It's a MCQ type question. The batsman did not hit the ball hard enough. Okay, this is the first question. First option. Second one, velocity is proportional to the force exerted on the ball. Okay. Third one in the next page. I'll go to the next page. Third one, there is a force on the ball opposing the motion. There is a force on the ball opposing the motion. I have underlined the question. Some force is there which is opposing, means trying to stop the movement of the ball, and there is no unbalanced force on the ball, so ball would want to come to rest. So what will be the answer? Third one. Okay, so there is a force on the ball opposing the motion, opposing the motion of the body. Okay, so answer will be option C. Ninth one, a truck starts from rest. Underline it. Okay, a truck starts from rest. One thing you have to remember, whenever you're solving any numerical in any numericals, so first you should read the question and underline it. Okay, and then you should start writing the given values. Then you will understand which formula to be used. This is my advice every time. First I'll read the question, I'll try to understand it. Okay, and if possible I'll try to draw a rough diagram also, for your convenience and to make you understand better. A truck starts from rest. Let us consider this is a truck. Okay, this is a truck. And truck is in the rest position, right? It means there is no driver. No driver came into the truck and he started accelerate. Now what happens? It will start from rest. So before that, the body is in rest. It means velocity. What will be the initial velocity? U value will be 0. I told you. So when body is at rest, okay, whenever you find the question rest, it means Initial velocity is 0. You should take u. What is u? U is initial velocity. Initial velocity will be 0. INITIAL velocity. U is equals to 0. We should take it because initially the body is at rest. This is a given value of it. And after that, and rolls down a hill, okay, and rolls down a hill with a constant acceleration. Acceleration is constant. It travels distance of 400 meters. So distance, which letter we take? We take s, okay, in force and loss of motion. So s is equals to distance, how many meters? 400 meters, and we need to check the units also. Now 400 meters, which unit is the standard SI unit, right? And after that, time, how much time? In 20 seconds, and time is given 20 seconds. So both are SI units. So we need not to convert the unit. 20 seconds. After that, find it. Now what is he asking? We'll see one more. Find the acceleration, find the force acting on it. If its mass is 7 tons, he has given mass also. M is equals to how much? 7 tons. 7 tons. So 1 ton is equal to how many kilograms? Because ton is not a SI unit, right? It's a bigger unit. So we need to convert it into SI unit. So 1 ton is equals to 1000 kilograms. Then 7 tons, it will become 7000 kilograms. So value will be 7000 kg. Okay, now these are the given values. Now what is he asking? He's asking to find acceleration. And he's asking to find acceleration value. Okay, so this is also one of the important question. So now you need to remember it. So first, what we do, we have to find acceleration. Na? So we have three equations of motion which we have studied in the first chapter. So let us see first equation of motion. V is equals to u plus at. We need to find a value. Okay, if we take this formula, okay, if we take this formula, is it okay? We can find a value. Yes, we can find a value, but we don't know u. Sorry, v. We know only u, and we don't know a. So without knowing two values, we cannot find. We know t. Okay, we know t, and we do not know v also. Okay, and we do not know a also. We do not know a. We have to find a, na? So we don't know a. Only one value. So, and we know this u will become 0. So without knowing v value, a value, we can't take this formula because it is difficult. Okay. So we can take one more second equation. S equals to ut plus s is equals to ut plus half at square. We take this formula. Okay. We take this formula. Okay. S equals to ut plus half at square. Now you see from this, is it possible to find out a value? First, you try to substitute all the values here. Okay, yes, how much? 400. 400. U value 0. So this whole ut will become 0, which is equals to half into a into 80 square is there, na? A into what is t? 20. So 20 means 20 square, na? So I'll write 20 into 20. 400. So it will get cancelled. So 20, 20. It will be here 400. And here also 400 get cancelled. Now what will be the a value here? How much you have? So a is equals to 2 meter. Okay, this 1 by 2 will go to another side now. So a is equals to 2 meter per second square. 2 meter per second square. A is equals to 2 meter per second square. I have cancelled this 20 and 400. Okay, 20, sorry, 20, 20. 20 square is nothing but how much? 400. So here left side you have 400. So both get cancelled. And the remaining will be half into a. So this 1 by 2 will go to another side. So 1 by 2 division becomes multiplication. So finally we find the um, acceleration value also. And he's also asking find the force as well. So now very simple. He's also asking find the force value. F is equals to question mark. What's the formula for force? Force is equals to mass into acceleration. So what is mass value? Mass 7000 kg. So 7000 into what is acceleration value? 2. 7000 into 2. 7 to the 14. Answer will be 14,000. See, units are very important. You should not forget writing units. 14,000 Newton. Okay, 14,000 Newton. Okay. So these are the first 9 answers. There are almost 24, 25 questions. Okay, I'll explain every answer. So we'll see the remaining answers in the next video. Okay. Thank you so much for listening. Please make a note and don't forget to write the given values. Try to understand the question and also write given values. If units are in different um, if units are different means they are not in SI units. If same quantity of units are not same or different, you need to convert into, you have to bring them into same system of units. Okay. Then later on formulas. Okay, substituting in the formulas after uh, calculating the, you have to write the units also compulsory. It is meter per second square. Okay, a value 2m by s square second square, because here the handwriting won't be good. I hope you have understood. Okay, so see you in the next video. Take care. Bye bye.